Welcome back. This is John P. Kelleher from Los Medanos College, and this is week 8 through 10. 8 through 10. All right. Now, again, we're going into the meat of fire suppression, fire behavior, and the actual fires. Just get me excited. I miss it. Okay. So again, I'm pretty much doing 2 or 3 weeks in one. So this is a longer lecture than usual. Then week 11 and 12. Week 11 is on wildland firefighting, and week 12 will be on hazmat materials. So let's go. Fire suppression. Most of fire departments use water to suppress fires. Why? It removes or cools the heat, removes the oxygen, and it's most easy to get to, i.e. fire hydrants. However, more departments are using Class A foam because it's a better knockdown of flames, less water, and fairly cheap. Especially on wildland fires, they're using Class A foam. Most fires will be Class A fires, wood, paper, and plastics, etc. And firefighters must consider these factors when suppressing a fire. 1, the length of time the fire has been burning. Remember the flashover. 2, the building construction material, occupancy type and its contents, and then the resources available, water, personnel, and equipment. All these things have to be considered when you actually fight a fire. The flashover can occur within 4 to 6 minutes of the initial ignition. This is why most fire stations are 4 to 5 minutes away. Building materials are highly combustible or non-combustible material, i.e. wood versus masonry. Talk all about that in building construction. Taught that for a while too. Interesting stuff. Occupancy type. Occupancy means the proposed use of the structure or the intended use of the structure. That's mean by occupancy type. Examples, a commercial occupancy is a dry cleaners or a restaurant. A residential occupancy is a house or apartment where you live, a residence. Contents usually will be predicated on what type of occupancy it is. For instance, furniture, clothing, residential, flammable liquids at a gas station. And then most people die in residential occupancies than any other in the United States. Most fatalities are residential homes. Resources. How many firefighters, engines, trucks, helicopters, tankers does a fire department have? Example, El Cerrito Fire Department, Richmond Fire Department, we had a first alarm assignment. On the first alarm, we had 3 engines, 1 truck, and 1 battalion chief. That'd be our first alarm assignment. Second alarm assignment would be 2 more engines, another truck, and another battalion chief. So the idea is all depends on the resources. So this all depends on these are all circumstances when it comes down to fighting the fire. The reflex time and fire load are 2 important points to fire suppression. We'll briefly review both. That being said, fire load is all that in the PowerPoint. It goes over breakdown. There's also a handout on that when I put it on Canvas. The types of fire suppress. There are several types of fires fought by firefighters. They could be wildland or ground fires, vehicle fires, structure fires, and rubbish fires. Vehicle fires involve all types of motorized vehicles. The engine compartment of fuel-burning vehicle has many types of flammable and or combustible liquids, i.e. gasoline, diesel, oil, hydraulic fluids. Most vehicle fires are predominantly Class B fires, but any type of leak or can be set up on fire, not just a gasoline-powered offered steering fluid. Vehicle fires involve 1,000 to 2,000 different types of plastics, i.e. PVC, polyvinyl chloride, which is extremely toxic. Probably even up to 3,000 now. And what you guys are doing in your generation is now with hybrids and electric-powered engines, a lot more plastics, a lot more different alloys of metals, okay, that you're going to have to be dealing with. Class A foam and water is mostly used for that vehicle fire, if you can use it. Rubbish fires involve any type of garbage accidentally or intentionally set on fire. Usually intentionally set in a garbage can or a dumpster fire. The smoldering cigarette to a person who is cold can be dangerous because of the toxic fumes and lack of excitement. You don't put a Scott on, you don't put an SCBA on. Because you put it on. What are you breathing in? All that bad smoke and all that bad stuff. You never know what is actually burning. People would be throwing away drugs. It's in the garbage can. You never know what you're taking in. So always be prepared and have that SCBA on. Be prepared. Flammable liquids and fire. We'll talk about hazardous materials in a couple weeks on another lesson, but we'll just cover on flammable liquids. Flammable liquids and explosive and unstable, unlike Class A fires. The flammability is based upon its explosive range. It's either too rich or too lean. Solubility is the degree at which the flammable liquid will mix with water. Materials that are soluble in water are called polar solvents. An example of that is alcohol. Now again, all this different stuff I talked about in the lecture, this is also supplemented in your definition and terms. So if it isn't on the lecture, it's in all those different handouts I submitted in Canvas. Materials that don't mix with water are non-polar solvents. Examples, gasoline, oil, hydrocarbon-based fuels. So again, you have your materials that are soluble with water, that means you mix with water. Those are polar solvents. Materials that don't mix with water are non-polar solvents, and that's gasoline, hydrocarbons, or oils. Most flammable liquids are not water soluble. They will either float or sink on top of the water. Specific gravity is like vapor density, only concerned with the amount of the weight of water. We'll talk about that in hazardous materials. Specific gravity means the weight of an object, or weight of a material versus the weight of water. In air or gas, it's compared. Vapor density it's the weight compared to regular air. We'll talk more about that in the hazardous materials. Specific gravity is like vapor density, only concerned with water. Specific gravity is the products of weight of a solid or liquid as compared to the weight of an equal amount of water. Example, liquid specific gravity is lighter than water, will float on top. So an example of that is gasoline. Gasoline's the weight is less dense than water. So on gasoline, if you have a pool of water, it's going to float on top of it. Flashpoint of flammable combustible liquids. Flashpoint is the lowest temperature at which vapors ignite in the air when exposed to ignition source. Flammable liquids are liquids that have a flash point of 100 degrees or below. 100, and below. Flammable or class 1 liquids that have a flash point below 100 degrees and a vapor pressure of 40 psi, are subdivided as follows. Class 1A is a flash point below 73 degrees Fahrenheit and having a boiling point below 100 degrees Fahrenheit. Example is gasoline. Its flash point is minus 38 degrees Fahrenheit. So if it's 37 degrees, minus 37 degrees Fahrenheit outside, gasoline will still ignite. Class 1B and flash point below 73 degrees Fahrenheit, 70 degrees Fahrenheit, and a boiling pressure at or above 100 degrees. An example is acetone. Class 1C has a flash point at or above 70 degrees Fahrenheit and has a boiling point below 100 degrees. That's an example of propanol. Don't have to know all this, but just these are examples. Combustible liquids are liquids having a flash point at or above 100 degrees. Combustible liquids are liquids having a flash point at or above 100 degrees. Below is a flammable liquid. Combustible liquids are subdivided as follows. Class 2 liquids have a flash point at or above 100 degrees and below 140 degrees Fahrenheit. Example, that's kerosene. Class 3A liquids have a flash point at or above 140 degrees and below 200 degrees, and that's diesel. Class 3B liquids have a flash point at or above 200 degrees Fahrenheit, and that's an example of regular lube oil that you put in your car. Ignition temperature is the temperature at which a material will ignite without an additional ignition source. Ignition temperature is the temperature at which a material will ignite without an additional ignition source. That means that it will ignite without some type of source. A match flame is 2,000 degrees Fahrenheit. Electric arcs are about the same, and the cigarette glow ranges from 550 to 1,350 degrees Fahrenheit. So that means that that's the temperature of a cigarette or a lighted match. LPG, know this one, liquefied petroleum gas. LPG, liquefied petroleum gas. Okay, now we're going into tactical considerations. And again, we'll go over hazardous materials, all these different products in a couple weeks. Tactical considerations, now we're talking about firefighting. These are what firefighters think about, their strategy, their tactics, how the strategy is the plan, tactics, how you put your plan into action. Tactical considerations, strategy versus tactics. Strategy is your plan of attacking the fire. Your tactics are the methods to put your plan into action. Basics of fire strategy are size up, rescue, exposure protection, confinement, extinguishment, overhaul, ventilation, salvage. Size up is the analysis by the first officer where he or she decides what to do and how to do it. It's a mental process before, during, and after the incident. Again, going back to these different types of fire strategy, there's RECIO, there's Lloyd Lehman's RECIO, there's REVIS, LA City talked about REVIS, but in any case, these are your basic fire strategies above. When it comes up to size up is that initial look where the first officer sizes the situation up and relays that message up to everybody else coming in. So that size up is very important, and it gives a mental size up of what's happening and relays that on the radio to everybody else, and that gives everybody a picture or visual of what to expect once they come on scene. Very important, the size up. That's pretty much the craft of the business. A clear, concise analysis of the situation based on prior knowledge and experience, evaluation of facts, potential change of the situation, and consideration of available resources. Remember, size up just doesn't happen on a fire. It happens in a car accident, happens on a medical emergency, as happens on a hazard material. It's all a mental picture that you size up the situation and you say, wow, we have some leaking product out there. Will that catch fire? Where's it going to leak into? Will be there an ignition source? Will it leak into a drain? Okay. These are all the kind of things you have to do a mental aspect, a quick size up to see where it's going and what's going to happen. Facts, probabilities, possibilities, resource available, decision, plan of operation. The best thing I learned when I was learning how to be an officer was, what do you got? Where's it going? And what am I going to do about it? What do I got? Where's it going? And what am I going to do about it? And then who's going to help me? Meaning your resources. That's your size up. Rescue. Okay, we're going over each type of basic fire strategy. Your rescue is to remove the persons from the place of danger and deliver them in a place of safety. Save human lives and to protect them from potential danger. Your exposure protection, to prevent a fire from extending to other structures, property, or areas. To minimize the loss of life, reduce the fire losses, and to prevent group fires and conflagrations. Conflagrations, that gigantic where everything meets, all these different fires meet. Another type of strategy is confinement. Confinement is to prevent a fire from extending to other structures, property, or other areas. To limit the fire to the smallest possible area and to prevent further extension of the fire. Extinguishment. Operations where you knock down or control the fire. Knockdown meaning that when we talk about knockdown, that is, you have flame, use your water, you knock the flames down, knockdown, as opposed to just controlling fire and knocking it down or controlling it and knocking it back. Overhaul, often overlooked. Overhaul. Actually, the most dangerous part, salvage and overhaul is the most dangerous part of firefighting. A vital operation where firefighters prepare the premises for release to owners and or occupants, and to also determine how the origin and cause of the fire occurred. To completely extinguish the fire or any other remaining fires, place the structure or area in a safe condition, and determine the origin and cause of the fire. Very important. Why is it dangerous? Because the fire's out, or pretty much out, and you're making sure everything's out. You're tearing things apart, which part of the job I enjoyed, tearing apart stuff. But that being said, that's when you're kind of tired, your adrenaline's down, you maybe take your Scott off because the fire's off, and now you're breathing all that bad toxic smoke. And trust me, my firefighters used to tell me, Captain Keller, put your Scott on, leave it on, blah, blah, because the old school taught me, take your Scott off, the fire's out, leave everything on. That's when you breathe in all the bad stuff. You don't want to do that. So salvage to protect the property from additional loss or unnecessary damage. So when you overhaul, you make sure everything's safe, it's not going to reignite. And then salvage is when you protect all that stuff that's important, that will not get damaged. For instance, if you have a fire up top on the second floor, on the living area, well, on the down below, the water may come down and drain on top of all the living room area and all the nice stuff. Well, you want to salvage that. You want to protect that. Put the fire out on top, but down below, you want to salvage it. You want to take it out or cover it. Cover the couches, cover the tables, cover the chairs. That's salvage operation. Salvage could go on during the fire. Overhaul is when the fire is done. Strategic objectives and putting your plan into action can be thought of in several ways. Again, I mentioned RECIO, REVIS, and Alan Brunacisi's rescue, fire control, and property conservation. Alan Brunacini was the fire god. Now his son is down in Phoenix Fire. In any case, he was a very, very smart, intelligent person, and obviously how can I call it, a nomad in this business. He's the one who created these different ways of fighting fire and for us to adapt to the modern way of fighting fire. And instead of doing RESCEO and REVIS, okay, with rescue, extinguishment, confinement, exposure protection, overhaul, blah, 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 he's saying rescue, fire control, and property conservation. Those are your three. So Lloyd Lehman's tactical mnemonic, again, was RESCEO, rescue, exposures, confinement, extinguishment, and overhaul. And place ventilation salvage. When we talk about ventilation and salvage, you can interchange that. Ventilation being opening up doors or open up windows. So you ventilate to get all that bad and gases and products of combustion out. Or you do vertical, where you open up a hole above the roof, get all the hot gases out, like we talked about with backdraft. And then also salvage. We talk about salvage. You can continue salvage during the fire. LA City or LA County's mnemonic REVIS. That was rescue, exposure protection, ventilation, attack, and salvage. These are all your strategies. And then Alan Brunacitti's methods of fire control from Phoenix. He believes rescue is the most important. Got to get people out. You can't replace people. You can replace the building, but you can't replace the people. Then control the fire, and then conserve and save the property area. Now we're going to our tactics. Going into our strategy. The two things we talk about in the fire service is offensive or defensive. How we take this, how do we put this fire out? Do we go in offensively, or do we go back, step back, and go defensively? Offensive mode is where the firefighters make an aggressive attack on the fire. You must have enough personnel, equipment, and resources to go offensive. If you don't have enough people in the middle of the thing, you're going to have to go defensive, back off. So you're going to have enough before you continue to go in offensive. An example is direct attack on the fire, or put a line right on the fire. So if you pull up on a car fire and it's just you on the engine, you got 500 gallons of water, you got 3 firefighters with you, you can probably knock down the fire. You got some Class A foam to knock it down. Okay, take a direct attack, knock that fire out. But when you have a working structure fire at a home structure, you have, like I said, 3 engines, a truck who does ventilation and ventilation and such, ventilation and overhaul, and also takes care of utilities, and the battalion chief. Then you have enough people. But if it exceeds that, then now you have to go to defensive. But if you go offensive, you got to have enough personnel and equipment to go in there. There's a big decision on that. So remember, there's a situation where you may not have enough personnel or equipment, and you cannot have to go aggressive attack on the fire. Example of indirect attack on the fire is you cover all the exposures and evacuate the building. So essentially, is what we call the surround or drown is. It's a situation where we had a big fire at a auto store, and essentially there were structures next to it. So we went defensive, and we just basically surrounded the area where the structure was, where the auto parts store was, and then protect the structures and created defensive mode, so nothing's going past that building, and that's protecting those exposures. So we went defensive on that. We couldn't go in and go offensive because it's too big a fire and we're going to get hurt or something like that. So the reality is we immediately go defensive, and we control that one area of the fire and protect everything else out. Called the surround and drown in business. In whatever mode or strategy you decide, you use the direct, indirect, or combination attacks on the fire. So when we talk about direct attack, you apply water or foam directly on the base of the fire. When we talk about the base of the fire, here's the fire, the flaming up. The base is right in that middle. So flaming up, you're at the base of that fire. You put in a direct stream right on that base of that fire. And remember we talked about thermal balance, how to not disrupt the thermal balance. Thermal balance is when you have 1,200 degrees at the very ceiling of a regular structure. It's maybe like 150 to 200 degrees down below. And then in between is maybe 700 to 800 degrees. So if I'm down on my belly and I'm staying low to the ground, it's maybe 200 or 300 degrees down below, okay? But when I stand up, it's 700, 800 degrees, and then at the ceiling, it's probably 1,200 degrees. That's your thermal balance. If I introduce water in a different pattern, not a straight stream, and I do just spray water everywhere, that's going to create imbalance. And suddenly now 1,200 degrees will go back down on the ground, and 300 degrees will go back up top, because it mixes everything in mixes. And that's when you get those steam burns. So that's what we were talking about. Oh, I didn't really touch on. That creates the thermal imbalance. So when you get blasts of water with straight streams of water, that's when you have a little disruption, but doesn't interrupt that thermal balance. And that's when we talk about, that's when I have to be with you when we actually do a structure fire. We do some training, live fire training. That's fun. Again, direct tackle is apply foam or water directly on the base of the fire. The water is placed in a straight stream meaning that it's in a straight stream, okay? A fog is when you create a fog, so it's kind of like a strong pattern. So like putting your thumb on before you wash your car, that's a fog situation. A straight stream is just shooting water in that straight stream. The fire is extinguished by a cooling effect or heat absorption capacity of the water or the foam. The heat is eliminated as quickly as possible, usually done on small or controllable fires. It all depends on what kind of water, people, and equipment that you have. Do not disrupt the thermal balance, as I talked about, by employing blasts of water to inside that structure. The indirect attack is apply water or foam in a less direct fashion by using a fog or spray pattern. Okay, the fog or spray pattern. And in the business we call on your nozzle, right to fight, left to live. As you turn your nozzle, right to fight is straight stream. Left, you turn left on your nozzle, that creates that spray, and that's to protect yourself from that spray because it's so hot, using the spray to protect yourself from the heat. So right to fight, left to live. Remember that one. But going on in indirect is take the average, when you apply water or foam, you take advantage of the water expansion ratio of 1 to 1700 water to steam to cool down the fire when you apply that water. So the bigger the stream, the bigger the pattern, fog, you're creating more. It's creating more steam, but you're protecting yourself behind that nozzle. Again, I wish I'll be with you if we do some live fire training. Can't do it in the class, but wish I could. Indirect methods should be rarely used. Have firefighters inside the structure or room because of disruption of thermal balance and that steam burn potential. I've seen literally before we had the full Nomex around our face, I've seen ears melt because of steam burns right behind them when we're doing live train burning or actually a fire. Got to be covered, fully encapsulated. And again, blasts of water, okay? You can do hydraulic, you can hydraulic ventilate, you can vertical ventilate. That's when we talk about ventilation, the coordination of both. That's all these different tactics together, working together. Indirect attack methods should be rarely used, again, disrupting the thermal balance. And the combination attack is use both methods at different times to safely and properly extinguish the fire. So what that means is you may want to, if a fire is so huge and it's blown and going out the door, you may want to spray pattern outside of the structure, okay? Direct stream or a fog pattern from outside, okay? Knocking that fire down a little bit. And then as you advance, as you're knocking that fire down, it's getting cooler inside, then you can go back inside the structure and begin your direct attack, okay? So that's the combination attack. But again, you have to know it, you got to know the fire and how it works. Hose line breakdown. The 1-inch hose line takes out about 10 to 40 gallons per minute. So that's like that hose line. So if you go your regular domestic hose line you use to wash your car, that's about 10 or 15 gallons per minute. The regular 1-inch line in the fire engine is 10 to 40 gallons per minute. 1.5 or 1.75 now, we call it the tack lines. Those are anywhere from 50 to 250 gallons per minute. Those are most often used attack lines. Those are our fire attack lines. And then the 3 to 5 inch supply lines, those are called the fed master streams. Those are 5 to 1,500 gallons per minute. That's how we supply our hose, okay? A couple of things that are not on the lecture, you may want to know about this. I think it's on the test, but you may want to know about it, is OSHA. OSHA is Occupational Safety and Health Administration. OSHA, Occupational Safety and Health Administration, a federal safety organization. And NFPA, National Fire Protection Agency, 1500, NFPA 1500, deals with firefighter standard for health and safety and requires, don't need to know this, but understand it, that during an interior structural firefighting operation in atmospheres that are immediately dangerous to life, IDLH, immediately dangerous to life, and that do not have lives requiring immediate rescue, at least 2 firefighters must enter together and remain in visual and voice contact at all times, okay? The RIC or RIT team, depends on what department you use, the RIC or RIT team, RIC being Rapid Intervention Crew, or RIT is Rapid Intervention Team, has an additional 2 firefighters ready to go outside of the structure and be placed outside just to protect those 2 firefighters inside. It's called 2 in, 2 out, or then the RIC team, while other firefighters are inside that structure. There's different patterns, different policies. You can have your RIC team as a working team while they're just sitting there outside the structure. They can actually be doing something, pulling hose or doing something else, but they got to be fully ready to go, and turnouts, helmets, from it, encapsulated, ready to go to take care of those firefighters if something goes bad. And then lastly, the last section is Incident Command System. We're just going to touch on ICS. You take more class on this. ICS 100 all the way up to 700. ICS is a method of organizing personnel and equipment to resolve an emergency, regardless of its size. It's a way of getting all those tactics resolved, getting all these monkeys off your back if you're the incident commander, the IC. ICS is also referred to as the IMS in other books, Incident Management System. The Army developed ICS in Southern California, refined it during the large-scale wildland fires in the 70s. I happened to be blessed in the 80s when I went to Santa Barbara County when ICS was just developed, and one of my battalion chiefs, Don Perry, was one of the writers of the original ICS patterns in California. Pretty cool. ICS Assemblyman Nicholas Petrus developed Standardized Emergency Management System, SEMS, S-E-M-S, Standard Emergency Management System, after the Oakland fire in the early 90s. And basically, it's a way in which all emergency responders work as one. One person, one boss, also called unified boss. One person, one boss, unified command. And then is getting back to the SEMS, that means Oakland will fight with El Cerrito will fight with Richmond will fight with Omaha, Nebraska. That's that ICS system. We're all on one page. That's the SEMS. We all should be working together. We should know what's going on. We're not speaking different languages. Once command is established, the IC, and by the way, the Petrus, he was an assembly person in Oakland. His house burnt down. He heard about that. Oakland, San Francisco came over. I was there at the Oakland fire. San Francisco came over. Oakland has we all use 2.5-inch couplings on the couplings and then 3-inch lines. Well, Oakland and San Francisco had 3-inch couplings. So they're trying to connect their different couplings because they're hose lines. They couldn't because one was 2.5, one was 3. That's not going to happen anymore. So Petrus heard about it. He said, now after we go on SEMS, we're all on the same page. We're all going to have the same equipment, all that kind of stuff. Once command is established, the IC, the incident commander, is the lead strategist and the tactical leader of the incident. He or she is in charge, and everybody else reports to him or her. ICS breaks the responsibilities into segments, and it's easier to manage. It's better known as the divisions and groups. Remember about the monkeys on your back, all these different things? Okay, once I give off an order, I'm going to release a division. That means I don't have to worry about that. I have a division leader, or I have a group leader, all these different geographical locations. The IC doesn't have to worry about that. He or she has to worry about the big strategy involved. So divisions are geographic locations, and groups are functional with no specific location. Know the difference. Divisions are geographic locations. Groups are functional with no specific location. Example of that is Division 2 will be on 2nd floor. Group will be rescue group. They're all over the building. 3rd, 4th, 5th floor. They're looking to do rescue, all these different floors. But Division 2 is taking care of the 2nd floor. Examples, ventilation is given to the first responding truck company, and they're referred to as the ventilation group. So now once the IC established the ventilation group, he or she at the IC says, you take care of your business in ventilation. I'm not going to tell you what to do. You do it. That's your job. Okay, that's your ventilation group. I'm done with that. That's how I said. You release that stress. Okay. Fire attack and extinguisher is given to the first responding engine, and they're referred to as Division A or attack group. For each group or division, they do their specific tasks, and the incident commander focuses on the overall plan of attack or the strategy. Okay? So that's your basic ICS, very basic. It goes much more in detail as we go through the state. Once you get your job, we'll talk more about it. Okay, that concludes week 8 through 10. We'll see you in week 11. Okay?